Hello children, welcome to your quantitative class. In today's quantitative reasoning, we are going to be looking at exercise 12. Well, I want you to get your books and your pen. Let's begin. Today, we are going to be looking at changing ratios to fraction in exercise 12a, and also the concept of squares and square roots in exercise 12b. Now let's begin first with the second, squares and square roots. Now on this table here, I carefully picked out whole numbers for you to learn your squares and square roots. For example, what is a square? A square of any number is the result of multiplying that number by the same number. For example, the square of 1 is to multiply 1 by 1, and the result is also 1. So the square of 1 is 1. Now, what about the square of 3? Well, the square of 3 is to multiply 3 by 3, and that gives us 9. So we can learn the square of numbers from 1 to 20. Okay, the square of numbers from 1 to 20. For example, we also have the square of numbers from 10 to 20 on this other side. Now, if we are going to look at the square of 14, it means 14 times 14, and that gives us 196. So kids, let's try to memorize the square of numbers from 1 to 20. 1 to 20. Now, let's also look at square root. Well, square root is the opposite of squares. Now, when you are asked to find the square root of a number, you are asked to find a number that will multiply itself, or that will multiply the same number to give that number. For example, if we are to find the square root of 1, the square root of 1, well, it simply means we should look for a number that will multiply by itself to give us that 1. Yes, the answer is 1, because 1 times 1 is 1. Now, you can also be asked, what is the square root of 16? Well, the square root of 16 means to look for a number that will multiply itself to give that 16. And that number is 4. 4. Well, the square root of 16 is 4. The square root of 16 is 4. Okay? Alright. Now, the same way, when we look at these large ones, what is the square root of 121? Well, the square root of 121 is 11. 11. Square root of 121 is 11, because 11 times 11 gives us 121. Alright, so this concept is very easy to remember, But first, we must try to memorize these things. Okay? We must try to memorize them, and we won't forget. Alright? Now, we're also going to look at the first exercise for today, which is 12A. 12A. So I'm going to try to zoom so that we can see it better. So we can see the examples from here. 2:10 is 2/10. So how did this happen? Well, it is very obvious from the first part that 2, which is the first number in the ratio, goes to the top. But 10, which is the second number, goes to the bottom. Alright? So when forming a fraction from a ratio, don't forget the first number goes to the top, which is the numerator, and the second goes to the bottom, which is the denominator. Alright, so with this principle in place, we can therefore start working on the exercises, the questions. Question 1 to 10. Question 1 to 10. When you are given the ratio, you form the fraction and write it down in the box provided. So with this, we can answer question 1 to question number 10. Question 1 to 10. Alright, let's move straight to the second example. Now in exercise 12B, the shape we have here is a letter K. Well, on the left side of your K, you have a 9 and 4, 25 and 34. Now, in quantitative reasoning, you've been told that when you can find one of the numbers, that way can lead you to finding the others. So once you understand one of the concepts, don't forget what to do. Move backwards by changing the signs. So if your sign was, for example, a plus to get that number, then you have to go back by doing a minus. If it was a division, then you have to go back by doing multiplication. If it was a square root, then you know you are definitely going to do a square to go back. Now, first of all, let's look at this example. Well, in the example given here, where we have a 9, on the left we have a 25 and we have a 34. What you must have noticed is that the 9 plus the 25 gives a 34. That's very correct. But to establish this concept, we must check by trying the same thing with example number 2. In example number 2, well, 4 plus 4 is 8. And so when you look at this place, it's actually an 8. Alright? So you see what we are talking about. Alright? So this concept works. It works. When we look at this second example, or the third example rather, and try to apply the same principle, you will discover that 25 plus 625 will definitely give you 650. Alright, so now we know how to get the number at this side of the shape. All we need to do is to add the number here and the number here for all the questions. Now, how do we get the number at this spot? Then it becomes very obvious that if we add to get 650, to get 625, we must subtract 25 from 650. That is the opposite of addition. So 650 minus 25 gives us 625. Alright? Good. Now, we know how to get this, and we also know how to get this. Now the question is, how do we get this next one? Alright, let's look at the same principle. If this plus this can give you this, therefore, to get this particular one, we will have to subtract 625 from 650. That's the opposite of addition, which is subtraction. You see? So you subtract 625 from 650. Your result is 25. So that is how to get that position. So when you are asked to find any number at that position, it is very easy. Just simply subtract this number at this position from this. Alright? Very good. Now, we have one position left, and that is this position. How do we get the number in that position? Well, it is not difficult at all. What we need to do is to simply find the square root of this number. So any number we have at that very position, we subtract this, we find the square root, and once we are able to get the square root, we subtract that square root from whatever we have here. Yes, we subtract the square root of this number from whatever is written there. Okay, now we are going to try it. The square root of 625 is actually 25, because 25 times 25 is 625. So now when we take that 25, which is the square root, and subtract it from this, our answer is going to be 0, and that is why you have 0 here. Now to establish this, we are going to try other examples. Let's see what happens. Alright, now let's look at other examples. Let's look at this first example. What is the square root of this number? What is the square root of this number? The square root of 25 from the table is 5. So when we subtract 5 from 9, we get a 4. So that is why the answer there is 4. Okay? When we also apply that to the second example, yes, this second example, we are going to get the square root of 4 is 2. Now when you subtract 2 from 4, you get a 2. So that is why we have 2 here. So you can see that this principle of using square roots and squares is not a difficult one at all. So look at the questions given here, about 10 questions, question 11 to 20. So try to answer these questions according to the concept that I'll be given in this video. Alright, so take notes. It's very important you understand this principle before you work on them. Thank you for watching. I hope you had a nice time. See you in the next class. Bye bye.